looking at 20 through 24 here. For number 20, a car traveling at 7 meters per second accelerates at a rate of 0.8 meters per square second for 2 seconds. Find the final velocity. So for this one, we are looking for, let me get out the highlighter here. We are looking for a couple different things. VI is 7, so VI, 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 that's in all of them. We also know that the acceleration is 0.8, acceleration, acceleration, and we are given a time here and here. The question is, find the final velocity. So you look here, you have everything you need to find the final velocity if you use this equation right there. So plug in your information and use that equation. Please notice that when we look at the other equations here, while we have the time also, while we have everything to solve for delta x, it's not asking for it. Up here we have time, but we did not have VF and we did not have X. We did not have VF and we did not have X. So that's why the top and bottom equations don't work for us. The middle two would work. We want the third one because that's what it's asking for. When we look at the next problem, we look at 21. A car accelerates at 3 meters per square second, negative 3 meters per square second. What from rest? So rest, well that's VI of 0, VI 0, VI 0, VI 0. What is the velocity at the end of 5 seconds? And what is the displacement at 5 seconds? So they're giving us time, of course time, and time. What is the velocity? What is the displacement? So when you evaluate these again, we cannot use the top one because it has delta x and VF missing, and we cannot use the bottom one because of VF and delta x. Again, we're going to use the two here in the middle to solve for each different part. When you look at the next question, number 22, a car starts from rest, VI, and it travels for 5 seconds, time, with a uniform acceleration of positive 1.5, acceleration, acceleration, acceleration. The driver then applies the brakes and causes a uniform acceleration of negative 2. If the brakes are applied for 3 seconds, how fast is the car going at the end of the braking period? How far has the car gone from start? Oh, you got 2 accelerations and 2 times. This means you have 2 calculations. So if they want to know how fast is it going at the end, before you can do that, because it kind of happened like this. The car, let's see, the car starts from rest, and if I put this on perhaps a position by time graph, starts from rest, so here's my 0, starts from rest and goes with a positive acceleration of 1.5 for 5 seconds, and then you have a negative acceleration that way. So here's the thing, we may or may not have gone past the 0. There's 2 parts to this whole mess. So for the first part, you need to figure out the final velocity with the first part. So because the final velocity for the first half is the initial velocity for the second half. So I think what I would do is to get that final velocity here, V final. I think I do this one. I do VI of 0, acceleration of 1.5, and time of 5. So whatever 1.5 times 5 is, isn't that 7.5? So then I would know that my VI was 7.5 for the first part, because then it says, let's see, how fast is it going at the end of the braking period? So then I have 7.5 is now my VI, and my acceleration is negative 2, and my time is 3. So 2 and 3 is 6, negative 6, and 7.5. So that's a V final of 1.5. Then, because you have 2 different accelerations, that's going to be annoying. So we kind of want to do this in 2 parts because our accelerations are different. Most of our other things we can say, oh, constant acceleration, we don't have that. So then we have to rewind, use maybe VI of 0, VF of 7.5 with the 5 seconds to find the displacement of that half, and then say VI of 7.5, VF of, I think I said 1.5, I can't remember, with the 3 seconds, and find the other delta x and add them up. Because we're going forward the whole time. Okay, it's a couple different steps in there. I think actually, what is that, 4 calculations? So a little bit of work on that one. Again, use the first half of motion and find out maybe VF and x. Then use the second half of motion, find VF and x. Okay. 23. A boy sliding down a hill accelerates at 1.4 meters per square second. If he started from rest, in what distance would he reach 7 meters per second? So we are giving us VF in this one. They're giving us VI as a start. They're giving us acceleration of 1.4. And then they say in what distance. So we don't want this one. But we have VF and VI and A, and find the distance. So I'd use this one. And then 24. A sailboat starts from rest and accelerates at a rate of 0.21 meters per square second over a distance of 280 meters. Find the final velocity, find the distance. So again, a lot of the same stuff, except for this time we are given, let me get out the highlighter again here. We're given displacement, we're given acceleration, we're given VI. So this would be an excellent one for VF. But then for, what was the say time? And then find the time, you could go back and use this one right here. You could use the calculated VF with VI and A and calculate T. Or, yeah, seems like that's your best bet to do. That'd be the simplest route.